All right, guys, welcome back. I was going to use that last problem, but I'm actually going to just move on with it and talk about it and the problems they use in your notes just to keep it a little more straightforward for you guys. So, all right, now we're going to talk about joint relative frequency and marginal relative frequency. These sound so complicated, but they're really not. All we're really saying, okay, so let's look at their definition. Ratio of frequency. Ratio. All that means is a fraction. But when we talk about a ratio, we're talking about something compared to something else. For us, it's going to be easier to use it in terms of a percentage. Okay. So this is really how we're going to be able to build arguments. So now you can say things like when you look back at our other ones, were you more likely to play a sport and an instrument or less likely to play a sport and an instrument? Were males more likely to work during the summer or were females more likely to work during the summer? Those type of questions. Now, whether they matter or not, they're just used to make informed decisions later on. And it's really important for you guys to start understanding how people come up with these ideas from given information, because a lot of our information comes from other people making assumptions based on information. So this is your chance to really start owning what information gets you. And I think that's a really powerful thing that everyone needs to understand how to do. So when we talk about joint relative frequency and marginal relative frequency, we're talking about the percentages of each cell. Okay. So let's just jump right in on how to do one of these. And remember, the percentage they're probably going to give it to you in a decimal. I always like to talk in percentages, so I'll probably change the percentage. But if we look at this, okay, so we're looking at juniors, seniors, major in the medical field. So we could, by the end of this, we could actually say, do we believe that there's more juniors or seniors in the medical field? Why? And if you look at the numbers, you can say, oh, well, okay, there's more juniors automatically in there, right? But we don't know if there's more juniors as a percentage. Like, if 5 people say they're going to do something, but there's 50 people involved, but another group 3 people do it, but there's only 4 people involved, 3 out of 4 is more than 5 out of 50. Hopefully, ratios make sense by this point of our mathematical career. So we have a two-way table over here. The two-way table shows the results of a survey that asks college-bound high school students whether they plan to major in the medical field. Make a two-way table that shows the joint and marginal relative frequencies. All you're going to do is write it as a fraction, okay? You're just going to write the answer compared to that section. So watch. They take you through it pretty easily. They add up all the kids. 680 total students were in the survey, right? So now, boom, you take every joint frequency and divide it by 680. That should make sense, right? So what this looks at right here, let's change this to a percentage, 18%. Out of the kids, 18% were juniors and said yes. Now you can break this down farther. It just depends what they ask you to do, okay? So the joint frequency tells you for that very, very specific piece of information. Remember, we know there were 124 juniors that said yes. So what that means is 18% of all the people were juniors and said yes. That's all it means. Don't look into this any farther. This is just figuring out what the data is, okay? 32% were juniors and said no. 15% were seniors and said yes. 35% were seniors and said no. Now, make sure this makes sense. All of these will add up to 100%, okay? Because these are all compared to the 680 total. It doesn't mean that 18% of the people. Because if you look, juniors, 18 and 32, well, that's not 100%. You're right, because it's not 18% of the juniors said yes to medical. It's 18% of the total people were both juniors and said yes. So it gets a little complicated. Don't let it go beyond that. Now we start doing the marginal frequencies. And this one, I that always bothers me when they make it 50-50. I just wish the problem would have been a little bit better. So all you really do is add. Okay, you can just add them up. Okay, so 18% plus 32% is 50%. 15% plus 35% is 50%. Okay, so what that means is we had 50% were juniors, 50% were seniors. They broke it up very evenly. And you could have seen that in the beginning. So let me just show you on the calculator real quick. That doesn't flip very easy. But 124 plus 219, that gives you 343, right? Well, 101 plus 236, 337. Now, the reason it looks close, that's very, very close to 50. That rounds to 50-50. So when you looked in the beginning, what that tells you is, what these two right here tell you is, half of the kids were juniors, half of the kids were seniors. Now we look at the yes-no part. Okay, now we can see some discrepancy. 33% of the total said yes. 2/3 or 67% said no. So if I was just going to grab a typical junior or senior, I can confidently say 1/3 of them are going to the medical field, 2/3 are not. But that's all we're doing in this section. So honestly, I like to use percentages personally, but you can leave them in decimal form as long as the information is correct. And my guess is, for your big ideas, use decimals, because that's what they use. But in the real world, percentages are fine, because that's how we really talk to each other. You're going to talk to people more likely with a percentage. And as you do your homework, this is really as far as we get into the homework. Oh, and they click through and they tell you about what all this stuff means. See how they use percentages? I'm glad I clicked into that. That people talk in percentages. People don't talk in decimal. You work with decimal. The real world is done in fractions. You know how many people, like 124 out of 680. You work with decimals. It's easier to add, subtract, multiply, and divide with decimals. And then we speak with percents, because we all understand out of 100. Okay? And let me see if I really need to go through. That's as far as you really need to know for your homework. But I'm going to go through a little bit more, just because I know some of you guys watch this and some of you guys want to do some extra. Feel free. A conditional relative frequency is a ratio of a joint relative frequency to the marginal relative frequency. You can find a conditional relative frequency using a row total or a column total in a two-way table. All this means is now we're going to say how many said yes and no compared to the row or the column. So let me just get into a question. It's easier. These are always easier to see with questions. I apologize. So now we have the same exact one we used before. But now we compare. See how it's the 0.18 divided by the 0.33? Remember, 33 was the total. So if I was just going to look at likelihoods, how many juniors said yes? 0.55. Seniors that were yes, 0.45. Juniors that said no, 0.48. Seniors that, let me click to. So you see how sometimes it's easier to read it. Given that a student is not planning to major in the medical field, the conditional relative frequency of that person is, so I guess the easiest way to explain this is, after you have your yes and no's, then we can go back and break it down. How likely is someone that said yes to be a junior? How likely is someone that said no to be a junior? I hope that makes a little more sense on this. So now we're breaking down the data inside our data set. So if I was just looking at the yeses, if I knew someone said yes, what is the likelihood that they were a junior? 55%. What is the likelihood that they said no in a junior? So these are split so evenly 50-50. In the real world, you couldn't make a definitive statement. I wouldn't be comfortable making a definitive statement, put it that way, because they're so close to 50-50. that I wouldn't say anything. But you can always say anything mathematically. You could say you are more likely to be a junior, and say if you said yes to be in the medical field, you are more likely to be a junior. Not much more likely, but yes, you are more likely. So that really takes you through everything that your homework will go over. And I went over a little bit extra just to make sure that everything made sense. And remember, everything should add up to 1 here because we had 100%. So get on our Zoom conferences, not on Tuesday. Tuesday should be a fun day for you guys. Get your mental health ready together, together and everything. And feel free to come talk to me. But I hope everyone's being good out there. Make sure you get your homework done, and I will hopefully see you guys on Zoom soon. Again, I apologize. This takes forever to sign off.